The objective of this activity is to enable the students to factorize a given number. Let's understand what are factors. Suppose you have a number like 28. Factors means divisors. That means the numbers which exactly divide the given number 28. So if you know which numbers divide 28 exactly, then actually you are finding the factors of 28. 1 divides every number. So 1 is a factor of 28. 28 is an even number, so it is divisible by 2. 28 is not divisible by 3, it is divisible by 4 because 4 times 7 is 28. And likewise, 5 and 6 do not divide 28. 7 divides 28 because 7 times 4 is 28. After that, 8, 9, 10 and all numbers after that, they don't divide directly. 14 divides 28, and after 14, 14 is half of 28. After half of the number, you will have the number itself. So now 28 will divide 28. So how many divisors does 28 have? It has 6 divisors or 6 factors. These are called factors of a number, the divisors. But if we are talking about prime factors, the prime factors of a number contains only the prime numbers and it is a product of primes. So 28 is divisible by 2, which is a prime number, and 2 can be multiplied by 14 to give you 28. But see, 14 is not a prime number. So we can break it further and write it as 2 times 7. And now 2, 2 and 7 are all prime. And therefore 2 times 7 is called the prime factorization of 28. What material will be used to perform this activity? We'll be using some colored chart papers and the geometry box instruments. Let's perform this activity now.
To perform this activity of factorization of a number, we have taken 16 identical square cutouts. As you can see, these are all identical cutouts and they are 16 in number. So what we are trying to do here is we are trying to factorize the number 16. That means we will be splitting this number 16 into two factors whose product is this number. So how do we do this? One way we can do it is to arrange all these 16 squares like this in a single line, and you will obtain a big rectangle here. So I am just trying to arrange all of them in a single line. Here we go. We are slowly obtaining a single rectangle, and likewise we have to make different arrangements using these 16 squares. Now you can see this. I have made a big rectangle formed out of these 16 small squares. So what is the width of this big rectangle obtained? It is 1, right? And what will be the length? Since there are 16 squares placed adjacently, so this is 1 and this is 16. So 16 can be written as 1 times 16, and therefore 1 and 16 are factors of 16. This is one way of doing it. The next way I am going to do is to arrange them like this, where you have 2 and then 2 more and then 2 more. So you keep on arranging them like this in rows of 2s. So what will happen? You will obtain yet another rectangle. As you can see, even if I am doing it randomly without pasting them, we are slowly obtaining a big rectangle. And here we go. This is a big rectangle. What is the width of this rectangle? Now this time it is 2. And what is the length? 1, 2, 3, 4, 5, 6, 7, 8. So 16 can be written as 2 times 8. Now 2 and 8, they are also called factors of 16. Likewise, we can make another arrangement where you have in a single row 4 different squares like this. And how do you arrange them now? You have to arrange them in rows of 4s like this. This is the second row, and likewise we can have a third row like this. So when you keep on pasting them neatly, you will obtain another square or a rectangle. So it's a two-dimensional shape which you will be obtaining. So I have placed them randomly and I'm just showing it to you how you can obtain a square in this case, obviously, because you have 4 along the length and 4 along the width like this. So this is resembling a square now. So what is the length of this square and the breadth of this square? If you see, this is 4 and this is 4. So the same 16 can be written as 4 times 4. So you can make these possible arrangements and obtain the factors. So 16 has factors 1 and 16, 16 has factors 2 and 8, and 16 has factors 4 and 4. And that completes our activity on factorization.